Hello, this is the next video in our series on hydrolysis of carboxylic acid derivatives. And in this video, we're going to hydrolyze an ester, and we're going to do it under base catalyzed conditions. We're going to do base catalyzed ester hydrolysis. I'm trying to explain something here. Okay, and that's called saponification. We call it saponification because we're making soap here. Hey, I'm trying to do a lecture. What? What do you mean it's? Okay, well, Professor Penelope here says it's not a base catalyzed reaction. It's a base mediated reaction. I'm not exactly sure what the pig's talking about over here, but maybe we'll find out in a little bit. Okay, base mediated. You sure about this? Okay, all right. Base mediated. Okay. So this was a way you could make soap. You know, back in the old days, I don't know, you killed some wild game and you had a bunch of lard or triglycerides, fat. You had some sodium hydroxide and you could make soap. So that's why it's called saponification. All right, so what we're going to saponify in this lecture is ethyl acetate. So we're going to take an ester, ethyl acetate, and we're going to react that with sodium hydroxide and water. There's our base, sodium hydroxide. And what we end up making is sodium acetate plus ethanol. Okay? So an ester plus our base, and we make a carboxylate, so the conjugate base of a carboxylic acid plus an alcohol. All right, and then this would be, if we had hydrolyzed a triester of glycerol, this would be our soap. And it would also have a very long chain of carbons. All right, so let's look at the mechanism of this reaction. All right, this mechanism is going to be similar to many nucleophilic acyl substitutions we've had. Any nucleophilic acyl substitution reaction is going to have a nucleophilic addition and a nucleophile elimination. Somewhere in the mechanism, the nucleophile elimination is going to follow sometime after the nucleophilic addition, and there may be some proton transfers sprinkled in there for added excitement. All right, so we're gonna start here with our ester, ethyl acetate. All right, and we're gonna need a lone pair nucleophile, okay, which is hydroxide from the sodium hydroxide. Okay, remember the sodium's just a spectator. Okay, we don't have March Madness this year, so we'll just have nucleophile additions, nucleophilic additions. Okay, and we'll have sodium ions as spectators. All right, and so that's going to do a nucleophilic addition, and like so, and that gives us a tetrahedral intermediate. There you go. And what's gonna happen next is we have a leaving group, that OET. So that's gonna leave. We call that a nucleophile elimination. All right, and that gets us to here. Wow. What is that? That is a carboxylic acid. I swear there's some lone pairs there. Okay. And we've got what just left, the ethoxide ion. All right. Carboxylic acid has a pKa of around 4.7. If you're acetic acid, maybe 4.74, depending on who you talk to. Ethanol has a pKa, the conjugate acid of this, of around 15 or 16. And so this acid-base reaction is going to happen quite readily. It's going to be exothermic here. So a proton transfer. And that makes our acetate ion plus ethanol. Okay, so in summary, we have a nucleophilic addition followed by a nucleophilic elimination followed by a proton transfer. Now you'll note we have two steps here where we're using a base, okay, of some sort. Here we're using a hydroxide, and here we're using ethoxide. All right, and only one step where we're generating a hydroxide or ethoxide, okay, and that, if I'm correct, Pink Penelope, yes, okay, that is why this is a base-mediated reaction and not a base-catalyzed reaction. All right, so there's saponification for you. Hope you enjoyed this video. Thanks a lot. Bye.